Hey folks, I want to take a few minutes to kind of sum up what we've learned so far in the CASEL curriculum and look at some of the terms that we're using and some of the concepts that we're going to be building on here as we continue to move through. First of all is the circuit. And of course, in a circuit, what we've been doing, we've got these batteries, right? Something like this. And then we hook up wires to these and we run them through light bulbs, right? And the circuit, of course, can be open or closed. If it's closed, then the charge can flow through the circuit, right? And it's going to be flowing like this around the circuit. And if it's open, if we break this or if we disconnect our wire, then of course the charge doesn't flow through anymore. And charge is that stuff that's moving, all right? Charge is what's moving through. That's not called current. Current is the flow rate. So current is telling us how much charge is moving through the circuit in a given amount of time. So how much charge is flowing through in a given time period is the current. And remember that charge can be plus or minus, and that really has to do with so that the idea is that any conducting material has a natural charge on a natural mobile charge on it. And if it's missing some of that natural charge, then we call that a negative charge. And if it's gained extra charge, we call that a positive charge. That's what charge is referring to. So when we think about the capacitor, for example, when we charge up the capacitor, one of the plates, so both of the plates, when it starts off, have their natural mobile charge on them, and when we charge it up, one of them ends up getting extra charge and one gets charge taken away from it, all right? And that's positive and negative. Resistance is the resistance to the flow of the charge through the circuit. And we found out that some things have high resistance, like a resistor, for example, or a light bulb filament. These things have high resistance to the flow of charge through the circuit. What I'd like to do, though, is kind of make an analogy here at this point. If we think about water flowing through a pipe, for example, and we think about the water being analogous to the charge. So if like the water is like the charge. So the flow rate then, the current, is how much water is flowing through the pipe or how much charge is flowing through the wire. We can increase the resistance by making that pipe smaller. That's going to resist the flow and it's going to lower our flow rate through the pipe. So that's what resistance is all about. We can lessen the resistance by making the pipe bigger, or what if we switch it into two pipes like this? That's going to lower the resistance. Now more water can flow through in a given amount of time, and that's what we do in a parallel circuit. Remember when we had the two light bulbs and we connected a third light bulb like this? So we had this kind of a situation with the battery pack over here. That was called parallel. And remember how it allowed this light bulb to light up brighter because it lowered the resistance through this part of the circuit. But what happened is, because we have a certain amount of flow through here, the flow rate was not enough through both of these now to light them up, through both of these light bulbs, in order to light them up. And so parallel, that's called parallel when we have them hooked up like this, right? Series is when you have the light bulbs all hooked up in a row like this. Okay, that's called series. We've been introduced to a capacitor, which has conducting plates, two conducting plates separated by an insulator. And each of those conducting plates is connected to say a battery or a generator or something like that. This is a capacitor. Now if you make these plates really, say, really long and thin, like let's say they were made of aluminum foil with some kind of plastic in between, and if they're really long and narrow, then I could roll them up and stick them in a can like this. And that would provide me with a capacitor with a very large surface area. And then finally, we started to talk about energy. We talked about how a battery is not actually a source of charge, but a source of energy. And we talked about how the Genicon, the generator, likewise is not a source of charge, and it's not even a source of energy. It transfers the energy from my muscles to the circuit. And what's happening is the energy is pushing the charge around the circuit. The energy is pushing the charge around the circuit. So the charge is not the same thing as energy. The current is not the same thing as energy. The energy is pushing the charge around the circuit. So think about it like this. Again, going back to our water analogy. Let's say I have a water tank, and you've seen these kinds of water tanks. They're for fire protection, like in near the old mills around here. Let's say I have a water tank, and I have a pump that's going to pump water up to the tank, okay? Now, it's going to take energy to pump that water up to the tank, right? Now, when the water comes out of the tank, it's going to release that energy. And let's say I have, if it's going into, say, a pool down here at the bottom, I could pump it back out again, right? And pump it back up into the water tower. So we could kind of model all these different aspects here. The charge would be the water itself. The current would be the rate of flow, say in gallons per hour or something like that, that's coming out, all right? The resistance would have to do with like the diameter of this pipe and these tubes and so on, these pipes, and how much resistance there was to the flow of the water through this system. And the energy would be what's being used to, would be what's pushing this up through here and lifting it back up again into this water tower, right? That would be the energy. So this pump would be like the battery or the Genicon. That would be the pump, okay? And I suppose if you wanted, you could say that the capacitor would be analogous to the water tower in this case also, because it is in a sense storing that energy. All right, just ask me any questions if you've got them.